Good afternoon, everybody. Welcome to class today. Thank you for joining me. Thank you for watching, whether you're watching live or you're watching the recording. I appreciate you all watching. Thank you, thank you. So over by the end of the day tomorrow, I'm going to have all of your lab assignments that have been turned in graded. Started looking at those today. We'll be putting a grade on those for tomorrow by end of day. So if you have, or just be aware of that, I guess is the better way to put that. And today we are starting to talk about Git. Our Git module technically started last Friday. So now we're going to start talking about Git in our live sessions. We're going to start talking about Git this week and next week. This week's going to be more about the basics of what Git is and how Git works on our local machines. And then next week, we're going to be discussing particularly GitHub and how we use GitHub for our projects. So those are the big things that we have for us this week and next week, as we are starting to talk about Git. And Git is sort of the big, important tool that we learn. It's something that can help. It's, basically at the core of a lot of stuff that we're doing in this class. It's also something that can help you in other classes. And in general, it's just something good to use, something helpful that you can use with projects and code, and it helps a lot to know how to use Git properly. And so in this course, we're going to basically learn the basics, right? It goes deeper than kind of what we learn in the class, but there are a few handfuls of set commands to where if you learn these commands, you're good for 95% of your Git interactions. You might run into something that's kind of weird on occasion, and usually a quick Google can help fix that. But most of what you'll need is really just one of probably 7 or 8 commands. So it's pretty simple. Pretty simple. And so we're talking about Git. And so what exactly am I talking about when I'm talking about Git? Well, I'm talking about version control management, or source control management, SCM. We'll look at the Git website where you get Git in just a few minutes as we get to start our demonstration today. And it is git-scm.com, I believe. We'll see that in just a few moments. But it's a version control system or source control management system. And you might be familiar to some degree about version control. Right? Like if you've used Word Online or Google Docs, you'll know that there's a version control system that's built into the software as a service, into the cloud versions of these word processing programs and spreadsheet programs, things of that nature. Like Word now, you can even work on the desktop version. But one of the things about these word processors and Office software suites that use version control is that there is one document across many different users. And so as one user makes a change to a system, then that change impacts every other person because it happens on the central document. In Git, or with Git, I should say rather, we kind of take that and we flip it on its head a little bit. And so instead of having one document and have everybody working on it, with Git, there are multiple documents. And the existence of sort of the multiple documents is something that we'll get a good idea of next week as we look at GitHub, because as we're starting here just using Git locally, when you're using Git locally, you're typically just using it for yourself to do source control management. But the big thing is that every person that's working on a particular project gets their own version of the code. And then they can make changes on it locally. They can save changes. They can update it locally, work on it, do whatever they want to locally. And then they can create what we call a pull request. And the pull request will send a copy of the file back to the central repository that can be accepted or rejected and put into the central repository of work. So this way, as you can probably understand why that would be especially good with code, right? I mean, imagine if two different people are working on the same thing. Two different people are working on the same paragraph in a document, for example. One person has one idea of a way to do it. One person has another idea of a way to do it. And so if they're working on a document where there's one document and the people that are sharing it are all sharing the same document, that first person that gets to it and makes the edits and the changes, that's the dominant document. So you can imagine if you're working on code and at the same time somebody else is working on code that interferes with your code or potentially breaks your code, or they could be deleting parts of your code, that's not great, right? But if you have your own version, somebody else has their own version, then a third person is looking at that and saying, this and this are good. This would work, so we can put this together. Let's go ahead and commit this to the repo like this. So that way you have the opportunity to reconcile changes and make sure that, everything's good. So not only do you have your own code, but you have the code that can contain the full history of changes. And we've talked about some of the reasons why this is beneficial. Code is an iterative process. So if you have multiple people working on the same stuff, things get deleted, things get changed, things get moved around. Right? But also if you're working on it on your own and you make some changes and things work, and then you make some more changes and things are broken, well, you can revert back to a previous state where things worked. Right? So you don't have to, maybe you ran out of undo states, right? You hit Control Z as many times as your computer would let you hit Control Z. And things are still broken. Well, you could just go back to the last working state and recall the last working state. So ideally, what we want to do is, as we're working, every time we've made good progress that works, we would create basically a state. Right? We would do what we call in Git, we would call it a commit. We would make a commit. So whenever we're ready, whenever we have made a lot of progress and we are in a good functional state, we make a commit. And so then if you get down the road and you do something that completely screws it up, you can go back to the last good commit instead of having to go all the way back to the start. Saves you a lot of time, saves you a lot of effort. Git was created by somebody that you might all be familiar with, and that's Linus Torvalds, the creator of Linux. Created Git in 2005. And as you can imagine, with Linux being an open source operating system where the core is open source, when you only have a few people working on a project, it's pretty easy to control. But when you have hundreds or even thousands of people, working on things like the Linux kernel now, you have to have a way to be able to keep everybody from running into each other, to be able to, allow everybody to work on these projects and make good changes. And so that's Git, basically. The development on the open source Linux kernel justified the need for Git. And then Linus Torvalds basically just pulled a Thanos and said, fine, I'll do it myself, and made Git to be able to use in his projects. So how does Git work? Right, you're not checking out something from a central repo. You clone it and you pull it. And so we'll look more at that next week when we're looking at GitHub specifically, how we take an existing code base and clone it, pull changes, do all this sort of stuff. This week we are looking more at local repos. But the thing about your local repo, after you've cloned it and pulled it, after you have it on your machine, is that your copy on your machine is basically now like a copy on a distributed server, right? So it's just a copy of the source code. So your copy of the code is just as good as anybody else's copy, even the central repo, right? Your code in your local repo is just as good as anyone else's on that have it elsewhere, or the remote server or what have you. Most of the operations that you do in Git, you do locally, right? You're doing on your own machine because, like we said, you're pulling a version down to your own machine. That version is your version. Your version's just as good as everybody else's version. So the changes that you're making on your local machine, and then you're pushing changes back up the line to be included in the central documentation. And so what you're doing when you are pushing changes back to the server is you're making what we call a pull request, which sounds kind of counterintuitive, right? Because you're making a push, but it's called a pull request. And so what that means basically is that as you push, someone else has to pull, right? So you are pushing, and through pushing, you are making a request to pull your code into the central repository, to make your version and the central repository version the same by pulling code from your version into the central repository. And so if we were to look at this graphically, we'd see something similar to this. Right, we have the server computer, which is basically our centralized repo. We have computer A, computer B, which are two different people that are working on documents. We can see locally, computer A and computer B have files, and those files have the full version history of that file, version 3, version 2, and version 1. And so both of those files on computer A and computer B are equally valid, right? Computer A and computer B, as well as the server computer, those versions of the code are all the same, right? Or I shouldn't say all the same because they could have made changes to them, but they are all as important as one another, right? So if I'm on computer A, I can make changes to the file, and I can make a commit, which would put another version in my local version database. So at that point, I would have a version 4 in my database. I could in turn push that back to the server and make a pull request where the server central repository owner looks at my version 4 and chooses to implement it or not. And in the case of implementation, it gets added as version 4 of the central repo, which would in turn update computer B here. Likewise, the next time they ran a pull of the central repo. And so what I'd like to do is I'd like to just kind of go through and do a very simple demonstration and just kind of walk through the process. All right, so let's have a look at that. So first of all, this is the Git website. This is the one that you'll want to go to get the Git software. It is git-scm.com. Then you're going to go to the downloads here, and you're going to download it for your computer, right? Whether you have a Mac, you have Windows, or you have Linux, you can download for any of these. We can see here that the latest source is 2.42.0 for Windows. If we were to look at Mac, there would be a different way to install. Linux, a different way to install. You just want to make sure that you follow the instructions for your operating system in terms of how you install Git. Once you install Git, you'll have it on your system. If I were to search Git here, you can see I have two things. I have Git Bash and Git GUI. Also Git release notes. For our purposes, because it's what everybody uses, we're going to be using the bash, which is the command prompt. And so I have a Git demo folder here. And so we can use a Git bash prompt like we would use any other command line utility. Right, so I'll open up my Git bash here. I use my Git bash for the purposes of these demonstrations. I could use my regular cmd.exe. It's the same, it'd be the same. I just have my Git bash set to have a larger font on it so you all can see it better in the video. But I can use this exactly like I would any other command utility, right? I can go to drive E. All right, I can go to drive E. I actually think in my command utility, I might have to do that. Yep. I can go to drive E. I can cd into my web 140 folder, which, we can follow this here. cd into web 140. Fa23. And then cd into git demo. And now I'm here, right? Like if I ran an ls, we'd see there's nothing in there. If I put a file in here, by just going new text document, and ran ls now, we can see my new text documents in there, right? So we can use this like any other command terminal that we can use. But I find it a bit easier to go to the folder where I want to go and right click. Because when you install Git, it will add some things to the context menu for you. I think it asks you if you want to put them there. Make sure you say yes. Otherwise, you can still get there using commands, but I like this a whole lot more. Because I can just right-click and in my context menu select Get Bash Here. And that will open my Get Bash command terminal already in the folder that I'm in. So if I wanted to then say remove new text document.txt, I can do that, and we can see here in the background that it's gone. Let's clear that out so we can write some more commands. So I'm going to put a file back in there in just a bit, but I'm going to make it an index.html just so we can work with that. In your module, it talks about setting up the configuration options. So I won't go over that here, especially since mine's already configured. I don't want to reconfigure it. We'll just let you read through your module for the configuration options. If you already have Git, or you want to make sure that Git is installed, if you don't see the Git demo or the Git Bash terminal in your context menus or in your start menu, we can run cmd.exe. We do it the same way. But one of the things that you might want to do if you don't see any of that stuff anywhere is run git --version. And that should tell you which version of Git that you have. So this would be a place where if Git's not found, it would tell you Git's not found. Git --version. And we'll put that here in our Git Bash terminal, just so you can see that. Now, we can see there that the current version that I have is 2.37.3.windows.1, which we saw on the website a few minutes ago that was not right. Or that's not the most current version. So if I wanted the most current version, on Windows, you can run git update git for Windows, I believe is the command. Yes. So we'll just update my version here really quickly, just so I have the most up-to-date version, so that we're all in the same version. Here we go, it closed it. Now we're removing the previous version of Git, installing 2.42.0.2. Just to make sure that I have the most current version of Git, so you're seeing the exact same things. Like, there shouldn't really be any difference. But also, if you have an old version of Git on your machine and you want to update it, if you have a Windows machine, that's how you do it. Well, we should be ready to go here in just a moment. We can get Bash here. And we're good. I should be able to run version now and see that I have the most up-to-date version. So let's check that out. Git --version. And I have 2.42.0.windows.2 now, which is the most up-to-date version. Now I am in this Git demo folder that I've created here. And I'm going to leave this folder here. And I kind of have my windows made smaller here just so you all can kind of see things happen in the background while we do things. And so the first thing I'm going to do is I'm going to run git init. Let me zoom in here just a little bit so you can see this command a little bit better. Git git space init init. This stands for get initialize. We're initializing get in this folder. I like to say that when we're running this, we're putting get in it, right? Like we're putting get in the folder. Because when we initialize get in a folder, that basically tells get on our computers to watch this folder for updates. Right? We can't execute get on files in a folder until we've told our computer that we want it to watch for files in a particular folder. So if I hit enter here, you can see initialized empty get repository in my get demo folder. And you might have noticed in the background that it created a hidden file. This would be a hidden file. I have show hidden files turned on here, but I have this .get folder, which would be hidden otherwise. So when you run that, it might not show you that. It might be hidden. But we can open this up and we can see what it installs in the folder. We can see there's a hooks folder here with sample hooks, an info folder here, some objects here, references, a configuration file, right? All that kind of stuff. Git makes that automatically for us. I have hidden files turned on just so you all can see that happen. So when you run git init, you might not see anything happen. And that is fine. The way that you would check if you don't have hidden files turned on would be to run git status. And so if you had git status, if you run git status without that .get folder, you get a very different message here. But since I have that .get init folder here, it tells me we're on the master branch. There have been no commits as of yet. And there's nothing to commit. There's nothing new that's been made. There's nothing that's been changed. If I remove this .get folder here, which I can do, now I've taken get out of this folder. If I run git status, now we can see fatal, not a git repository. So if you don't have hidden files shown, you can run git status to determine whether or not you successfully initialized git in a folder. I'll run git init again. You can see that .get folder pop back up and everything's cool. So I'm going to create a new file here. We could do it manually here. We could do it via a program like VS Code. We can do it via our command line here. I think I might try to do that. fsutil file create new index.html 0. And just run my command, my file system utility to create a new file. Here that is index.html, and here it is. Right, so this is just a file. So if I open it in Notepad, there'd be nothing in there. So let's just put an HTML skeleton in here really quickly. Just so we can have something here. And so now that we have a file and we've made changes here, we would want to first add these files to the Git repository that we have locally here. And we do that by running git add, and then I like to always do git add period. Git add period will look at your initialized folder, and it will take any new or changed files that are in that folder, and it will add them to the staging area. So I can do that. To see if it's successful, I can run get status. And now we can see it's changed a little bit, right? Like when we ran get status up here, after we first initialized Git in the repository, when we hadn't put any files in there yet, we see on branch master, no commits yet, nothing to commit. Create copy files and use git add to track. Well, now we've used git add to track a file. Right? So we have on branch master, no commits yet, changes to be committed, new file, index.html. And so now I can commit this to my repository. So I'm going to run git commit -m. -m stands for -message. I want to add a message to this. And the message here is just a brief message that talks about what this commit did. Right? And so in between quotes here, I'll put added index.html. Right? Something like that. And hit enter. And now we can see on the master branch, we added index.html. That's one file changed, 7 insertions, which is 7 lines of text changes. Right? If we look at our index.html, 1, 2, 3, 4, 5, 6, 7. So we get this information that we have created a commit, which is a status of our project, or it's a state of our project, something that we can revert back to if we want to. Right? So if we run git status now, we can see that my working tree is clean because all of the changes that I've made have been committed. But if I ran a get log, log, then it shows me all of the commits that have been made. And it shows me the hash for this commit. This commit is hash 323d34577809d, so on and so forth. Right, and so this is the commit where if we wanted to revert this file, we could go back to here. And we don't have to put all of these in. You can just put in the first few. And it's unique, so it'll figure it out. And we'll do that here in a moment. But let's first go in here and make a change. Let's add an H1, and we'll just add a hello world in the body here, /H1. And we'll save that. So now we can git add period, right? You go through the same process. After you've made changes, you go through the same process. So I've made my changes. I'm at the point where I want to make a new commit. I go through my process and I say, okay, now I'm ready to make a new commit, git add. And then I'm going to git commit -m added H1 of hello world. And so now if I look at my git log, I'll see 2 statuses. Right? I'll see this first commit and this second commit, and they go in reverse chronological order. So the most recent one will be at the top. So this first one's where I added hello world. This second one is where I added the index.html itself with the HTML skeleton. So let's say I did some work in here and I made some changes. And I changed this H1. We could just think about this in terms of making bad decisions in our code or messing up our code. And let's even say I went as far as to go ahead and make a commit of this, right? So get add period, right? That's one of your... So our biggest commands so far are get init, get add period, get commit -m plus whatever comment we want to add, or whatever message we want to add, and get status. All right, so we'll add it. We'll commit it. And then we say, oh, we messed up. We messed up. I don't want it to be that. I want it to be hello world. I want to go back to this version. Right? So I could look at my log, get log. And I could see like, okay, like made this change here. This was the last change. So that's probably where I want it to revert to. And I want to kind of arrange this so you can see this file while I'm typing this. So I'm going to type get revert. And then I'm going to start typing in the commit hash for the commit that I want to revert to. C637BE, that's probably good enough. 5 or 6 characters typically is good enough. It's going to be able to scan them and see, like, it's going to be a unique value. We should probably be able to work with get revert C67BE or C637BE. And then it tells me auto merging index.html, merge conflict in index.html could not revert. After resolving conflicts, mark them with get revert, continue, so on and so forth. Right? So this is something that you might run into. As you're trying to resolve conflicts. This is what we call in get a merge conflict. As we can see here. And so typically what we would do here is we would merge our paths into one path. Now, it would typically be easier to do this in a more robust sort of file manager. But we're going to try to do this here in command line so you all know how to do it. And so the first thing that I'm going to try to do is I'm going to try to merge my log. So I'm going to say get log -- merge. And so what this will do is this will produce a list of commits that are causing the conflict. So it's asking me about merge head. And so that's kind of what we're getting into here, is that we would need to merge the head here. Probably. So what I want to do instead is I want to run get merge to see what that does. Merging is not possible because you have unmerged files. Fix them in the work tree, and then use get add rm file. So let's then abort our merge. Get merge abort. No merge to abort, so we're good. Let's look at get status. And now we see our unmerged path. So I'm currently trying to revert commit. So let us unstage this file. So get restore -- staged. I'm just going to follow what it says about the unmerged paths here. Index.html. And then I'm going to get add period. And this should have fixed me up. So now I can run get status. And we can see we have staged my file. So let's try get revert -- continue now. Now it's waiting for my editor to close the file. So I can close this file. So I think it's going to work this time. Open with. We're going to open this with Notepad. And that is strange. That shouldn't have done that. Huh. That's a weird one. Let's try running that again. Let's try running our revert again. Now it's in conflict again. Let's get revert abort. And, you know, sometimes I should say that sometimes get is just like this. Get add period. Get revert C637BE. Get status. And it might be that did I close that or did I leave it open? I think I closed that file. So let's just get restore staged index.html. Unstage that. Get add period. Get revert. Get commit -m test. Get add period. Get revert. Conflict. Oh, it's throwing these conflicts at me. I do not like it. So let's try something else here. Let's get revert -- abort. Let's get status to make sure we're clean. If we look at our index.html we see it looks like this, which is not right. That's not how it should look. So let's try to check out instead of reverting, which adds a step to it, but since reverting is not going to work, then it is what it is. So let's get checkout C637BE. So now we're in a detached head, so that's fine. We should be able to look at this now. And there we go. That's what we want. So that's going to work. This is going to add the step of I need to reattach the head, though. So I can do this by creating a new branch, or I can just get add period and get commit -m reverted to previous. Get switch -c reversion branch. So now I have a branch called reversion branch, and that's what we're on now instead of our main branch. And that's only going to matter when we go to push to a repository. That's going to help us figure it out, though. Merge conflicts are kind of a pain when they happen. So you just want to make sure that you kind of fix it the best you can. I don't like making a new branch often just to fix this sort of issue, but it's fine, right? So now I'm on a new branch and I can do everything I need to do from here. So at this point, we've really seen basically everything that we would want to see from what we would be doing. You're often not going to be doing a lot of reversion and going backwards and trying to fix things that way. You know, it's mostly going to be making changes and adding things, like if I wanted to add a paragraph. Then I'm going to go through my big steps again. I'm just on a different branch now. So I'm going to get add period, get commit -m, added paragraph. Now, if I look at my get status, or my get log rather, we see since I'm on a different branch, then I only have 2 commits on this branch. But if I switch back to my master branch, let's see, what's the command to switch branches? What's the command to switch branches? Oh, it's switch, right? Yeah, it's get switch master, and then run the get log from here. And then we can see that it is commit 6F A728F is the last one, or the most recent one in that branch. Whereas Control C, come on. Control C, escape. Come on, don't do this. Get oh, what's the thing I'm looking for here? I have forgotten what command I use for this. On other things I use, this is where you'd use Control C in other terminals. So let's just kill the terminal and open it back up. We can see we're on the master branch here, so we're going to want to switch to the reversion branch. Look at our get log to make sure we're in the right place. We're going to want to make sure that we save and do get add period, get commit -m, added paragraph. And now if we look at our git log, we have where we've added the paragraph here. And so I'll go through this quickly here now. Next week, we're going to be using GitHub, or we're going to be talking more about GitHub and how we use GitHub. So I'm just going to show you briefly uploading the file in this process. So I'm going to create a new repo by clicking the new button here. I'm going to name it Web140 Fa23 basic git demo. Right, so since there's no real code for this assignment, you won't be getting a code file for this, but I'm going to click create repository here. And so it gives you the commands here. And so what I can do is I can just follow these instructions that it gives me here. Since we already have an existing repository, I can follow this second set of instructions. I can copy this command to create a remote origin. The remote origin is the server where I'm going to be pushing this file. It is now called origin. I can change that to be basically whatever I want to call it. Right? It doesn't have to be origin. But when I get to this command, whatever I rename it is what I need to call, what I need to put here instead. So if I wanted to call this remote, for example, I can call it remote. Just when I get to this line where I get push, I have to push from remote. And so right now it's called reversion branch, so I can get push -u remote space reversion branch, or I can rename my branch to main, right, by doing get branch -m, uppercase M main, and that's going to rename the current branch to main. And now I can get push remote main. And it's going to do its work, and it's going to zoom, and it's going to send files across the internet. So now when I refresh this page, there's my index.html. And what's also cool is that when I look into here, right, it says 3 commits. These are the 3 commits on that particular branch. When I look here, I can view all branches. There's only one branch that's been pushed. It's the main branch. But I can see all 3 commits that have been pushed on that main branch. One of the things that we'll do next week as we're talking about using GitHub itself is we'll talk about how I would take and pull this code, bring it down, make copies of it, and push it back up. So that's a lot of stuff, but remember our big commands again are going to be get init, get add period, get commit -m with a message, get status, get log, and then the commands that are given to us on GitHub. And if there are other things that pop up, we can use get checkout to revert back. We can make a new branch and switch branches using different things and so on and so forth. So as we wrap up today, we'll wait on questions to come in. If any questions come in, while we're waiting to see if questions come in, I'll just talk briefly about the final project, which you will see that I put the notes about the final project out at the end of the week last week. If I look at our course here, we get this window to drag over if it wants to be cooperative. This link that says my group has always been there, but it didn't work previously. Now it's going to work for you, and it's going to take you to your group area. You can see your group members here. This is a way that you can contact your group. It has your degree area that you've been assigned here. These are tools that you can use that I'm giving you to use, but you don't have to use them. Come on. Also, as I mentioned here in this announcement, I put you all in one group. And the way that we're going to handle that is multiple people are going to take on 2 of the tasks. So we'll have 2 people taking on one task, 2 people taking on another task. Then for the other tasks, it's just one person taking them on. It's your responsibility, your job to divide up the tasks among each other and figure all of that out. So make sure you do that. As I state here, I like to try to remain as hands-off as possible. You know, one of the goals here is to help you all kind of develop some soft skills and communicate with one another. So if I need to step in and help you all figure some stuff out, I will. But ideally, you're going to try to work it out amongst yourselves first. And remember that you are, even though it is a group project, you all are being graded individually. And so if you have any questions about that, send me an email, what have you. But seeing no questions come in at this time, we'll go ahead and stop here. We'll pick up from this point next week and talk more about Git and subsequently GitHub. That's all that I have for you for today. Thank you for watching. We'll see you next time.